You are doing so well for following all this lesson up until this point. Right. So now that you have some basic knowledge in Python, doing NumPy and understanding what NumPy can do, let's delve more into more complicated data set or giving data that has a lot of um, stuff in it, like it has a lot of data points in it, so that we can deal with that. Okay, so for now, we'll generate our own data, and then at some point we'll have to work with the real data. Okay, so what we want to do in this video is to get access to some of the Python or NumPy statistics that we can do given a NumPy array. Okay, I think this is going to be the last thing we talk about NumPy, and then we'll move to pandas and other stuff as well. Okay, all right, so here, as usual, you import NumPy as np before you can use the NumPy package. And then this line I have here is set seed for reproducibility. What I mean by reproducibility is that so the np.random.seed 125 here, make sure you use the number 125 inside as I've used here, so that you get exactly the same data I'm going to get here when you also run this code. Okay, so make sure all these lines are the same on your side. So now we want to generate the data using np.random.normal, and here, if you're familiar with statistics, this is we're going to use a normal distribution, which I mean, if you know more of stats, you understand what it means. But that's what we're going to do. If you don't understand statistics, that's okay, because Python can do it for us straight away. Okay, so basically what we are doing is we want to generate a data called height. Okay, using the np.random.normal distribution, or dot normal, which that code actually takes in this argument, the distribution mean. So if you have a normal distribution, most of the time what we want to know is the mean for the distribution or for the population, the standard deviation, and then the number of samples, or the total population number. Okay, so here what we want to do is we want a distribution that has a distribution for the height, like a normal just random distribution with a mean of 1.5 1.75, and then standard deviation of 0.25. And then how many numbers do we want? We want 5,000 of these data points. We want how many data points do we want for the height? We want 5,000. And then this two here, and then the round here. This round means that for every data point I pick, it should round it up to 2 decimal place. Okay, that is what the last two part means, and it's coming from the round part. Okay, and it's a NumPy method, so that's why I have the round np.round there. Okay, similarly we do same for the weight. So here what I'm trying to do here is that I'm trying to generate a data of that consists of the height and weight of 5,000 people living in a particular town. Okay, so you can name that town the way you want it, and we want to get this height and weight of these people and then perform some statistical operations on them. Okay, so that we can make some conclusions out of that. All right, enough of the talking. Let's start with actual work. So here, if you run all these code, the np underscore town here is the town name. Okay, so like I said, you can actually make it maybe np underscore Ghana, or maybe np underscore Kumasi, or np underscore KNUST, wherever you're watching this video from. If you want to name it the way you want, that's fine. Okay, and then this np.column stack here is to say that we want to create a 2D NumPy array with two columns, the height column and then the weight column. Okay, so that is what it means. Now if I run this block of code, of course NumPy has it done, everything is done in there. If you want, we can actually print np underscore town to see how it looks like. Okay, if we run that, it should give us so we have, yes indeed, we have a two-dimensional NumPy array with how many columns? We have two columns. That is the first part of each one of them, and then number of rows we have 5,000 of them. Okay, because each data point is going to contain the height as the first column. Second column is the weight, right? So here the height for the first one is 1.58, and then the weight is 56.98 for the person. Okay, so that is how it goes by. Now the dot dot here that we have means that we have a lot of, or a bunch of data inside there, okay, between the first three and then the last three. Okay, so if you want to know how many data points, which is the rows, how many of these copies, right, how many of these pairs are we going to get? If we run the shape, it's going to tell us how many rows. We have 5,000 rows and two columns, so it means we have about 5,000 of these set, each one of them having the height, weight, okay, 5,000 of them. So you can use the shape. Like I said, we've done all these things in previous lessons. So this part of it was supposed to show us how to generate this data and work with it. Okay, so now let's try to calculate the mean height and weight of the people living in the town. Okay, so here what we want to calculate, we can use, so let me say mean height, or mean underscore height. Okay, and how I'm going to calculate that is going to be equal to np.mean. Okay, and the height here is actually the first column. All right, so the first column, how do I subset that? I want to go through this whole data, right, and subset every first element in each row I pick. Okay, so I'm going to go through all these rows, make sure that I'll take the first element. So here the first part is I'm going to use column, and this, if I use column for it, it means go through the whole of these rows, and then I talk about which column I'm going to talk about. The column here, NumPy or Python start indexing from 0. So instead of us calling this column 1 and column 2, NumPy Python sees this to be the 0th column and then the first column, right? So I mean, in practical, this is the first column and this is the second column, but in indexing, Python sees the first one to be the 0th one, right? So I mean, I'm talking about this first column, but go through each row and pick the first element, right? So in that, this is how I calculate that, and I can find the mean weight as well, right? So I'm finding the mean weight and mean height. Okay, so I'm doing the same thing. The only thing I do is change that, go through the whole of the rows. The only thing I change here is the column, right? So I mean, this, if I print let me print this and see. All right, so let's print and say that, let's use the f print. That will give us the opportunity to write some things. Okay, mean height, let me just do this, and I'm gonna write this guy. Okay, most of the things I will just leave it for you to do, right? And then I want to set this to 2 decimal place, right? I mean, when I do this, it's going to set it to 2 decimal place, and then what I do is mean weight, same thing here. Okay, all I change is weight here, right? I hope mean underscore weight, right? So everything looks perfect here. We can just print this and see what happens. Okay, so yeah, so if you print this, we have mean height 1.76 and mean weight 50.27, right? So if you go ahead and start to calculate other statistic properties, we can calculate the median height and median weight. Same way we can copy the whole of these and make some small changes to them. What we can do is go to median, So here all we can do is median, and then we change this to median, right? So it's not that difficult. The normal statistics name that you know is what we use, okay? So here all you can do is median height, here change it to median weight, change this to median, and if you run this we should get something, right? Let me see what's happening, that I'm getting the same thing. So wow, this is so strange, but let's see. Median np.median, and I mean, it's possible, right? It's possible that we get, the only difference is that the median weight, if you check it very carefully, this is 50.47, this is 50.27, right? So if you want to make some inference based on these things, or make some conclusions based on these outputs, then you can use them, okay? We can go ahead and calculate the standard deviation. And again, so we can just use STD for standard deviation, and the same thing here, STD, standard deviation, same thing goes into this, standard. So let's use STD here, STD, and then STD as well, right? So all we do is run it, and we have the standard deviation for that, right? So here, ideally, if you go back to the standard deviation for the distribution we provided, ideally this is perfect, because this gives us back exactly the same standard deviation, because that was the distribution, right? And this was supposed to be 18, but it gave us 18.01, right? So it means everything is not that perfect. 18.03, so but it at least is very close to what we started with, right? So we can go ahead and do maximum, minimum. Let me do the maximum part for the height, and then you do the minimum part, okay? And let me do the minimum part for the weight, and you do the maximum part, okay? So these are that easy. Max, and this is max as well, right? This is mean, and this is also mean. Sorry. All right, so if I run this code, the maximum height is this, and then the minimum weight is actually negative 8.770, right? So we can go ahead and do some other percentiles. So let me just calculate the 25th percentile for the height, and then you do the 75th, right? So for practice you can do other percentiles, okay? Let me just write here percentile, maybe percentile underscore 25th, right? And what I'm going to do here for this one is np.percentile. When I go here, I have to specify which percentile I want, and I'm saying it's 25th percentile, right? And then when I come here, the same percentile, but I want the 75th percentile for the weight, okay? I come here and do percentile as well, and then I have to specify 75, okay? So here, one thing is that this part is just the name of what we want to do, that is the assignment, but this part is actually the code that does what we want to do, right? So for all of them, that's what it means. And so here I can write 25th percentile, percentile for the height, right? and all I've got to do is change this to percentile underscore 25. Okay, here I can change to 75th percentile. Okay, for the weight, right? And all I got to do here as well is to change this to percentile underscore 75, right? And if I run this, I should be able to get some values, right? So this is 1.57, that is the 25th percentile, and then 75th percentile for that one. So we can do the other percentiles, right? So the assignment for this particular video is for you to do other percentiles, the maximum and minimum of everything. You can also go ahead and do yeah, the other percentiles, like I said. And then let's try to calculate the correlation coefficient. Okay, so here let me name it as coefficient, right? Coef or something like that. And I'm saying this is equal to NP dot the same thing, correlation, so correlation coefficient, and then I'm gonna do NP underscore town, and I have to supply this with the two data I want to the two data I want to find the correlation coefficient between them. And if you've done statistics, you need an x and y kind of values to check whether there's any correlation between the x and y, right? So I want to see the correlation coefficient, or the relationship between the height and the weight, and see if they have something in common. Okay, now if I print this, I want us to check something before I write the actual correlation coefficient. Okay, so if I run this, I should have my correlation coefficient. Here I have something that is like a matrix. It's like a 2 by 2 matrix that have one here and one here, and the other one has negative 2.7 something, and this also has negative 2.7 something. What it means is that this is a matrix of 2 by 2 matrix, and the first part of here, one here, is the correlation between the height and itself, and definitely the correlation between any data with itself is perfect, right? So it's perfectly related, so we're going to get 1. And the other one is also for the weight, but the off diagonals, or maybe the other ones here, they are the same, right? These values are the same. That is the correlation, actual correlation between the height and the weight. Okay, so how do I subset that? If I want to print that, I have to subset it using our subset ideas, right? So row 1 and then column 1, we can row 0, so this row, right, and then this column, that is this value. We can actually also subset it from here, right? Row 0 and then column 0. I mean, we can actually do 0 1, right? So 1 0 instead, right? So we can do 0 1. If I print this, let me see, 0 1. If I print this guy, I should get the other ones, right? This value, right? Now if I change it to this other guy, row 1, that is the last one here, and then column 0, it should give me the same thing, right? Already we had negative this, and this minus 4 here means it's times 10 to the negative 4, right? That's why we have those things there. And then we have the same thing. So if you want to perform some statistical operations on your NumPy array, or maybe 2D NumPy array, it can be a 1D NumPy array. That is how you do all these things. In the next lesson, we're going to look at plotting, right? Visualizing our data, and I bet you don't want to miss all those things, okay? Because that is where the actual work begins, where we can visualize and make some insightful deductions out of our data. Stay tuned, and don't forget to subscribe to my channel if you have not subscribed. If you've subscribed to my channel, thank you so much. Like my video, comment, and also share for others to benefit as well. See you.